starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited packages, starting at just 5,900 rupees per month. Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable. SLT Mobitel Fiber, now with unlimited
Good evening, everyone. Thank you for joining us and for your patience. We are facing a little technical issue in our side. We will start our session shortly in few minutes. Please stay connected with us.
Enjoy blazing speeds from 100 Mbps to 1000 Mbps with unlimited data and voice packages. Unleash the unlimited revolution with SLT Mobitel Fiber. Fastest, most stable, unstoppable.
Once again, good evening, everyone, and a very warm welcome to you all. I'm really excited to have you here with us today for this entrepreneurial workshop on From Idea to Market, Validating IoT Solutions, conducted as a part of SLIoT Challenge 2026. This session is happening for the university and open category, specially designed for university students, open innovators, and aspiring entrepreneurs who want to turn their IoT ideas into real-world solutions. Whether you are at the concept stage or already developing a prototype, today's insights will help you understand how to validate your ideas effectively before taking them to the market. The SLIoT Challenge is Sri Lanka's premier IoT innovation platform organized by the Department of Computer Science and Engineering, University of Moratuwa, in collaboration with SLT Mobitel and the Institution of Engineers, Sri Lanka. As part of the proposal submission stage, we have invited industry experts to guide you through key entrepreneurial steps from understanding market needs to testing and validating your solutions. And also, we would like to inform all our participants that due to overwhelming demand, the proposal submission deadline has been extended until 2nd of February. So hurry up and register soon, everyone. With that, I'm delighted to introduce our renowned speaker for today, Dr. Nimantha Baranasuriya, the co-founder and CEO of Thermotune and a startup advisor who has guided many aspiring entrepreneurs. Dr. Nimantha has years of experience in mentoring startups, helping innovators transform technical ideas into successful market solutions. In this session, he'll cover how to identify the right problems, validate your IoT ideas, and align them with market needs. The knowledge that will be invaluable as you work on your proposals. So, get ready to take notes, ask questions, and make most of this opportunity. Without further delay, let me hand over the virtual stage to Dr. Nimantha. Sir, the virtual stage is yours.
Thank you, Matumai. And thank you to the organizing committee as well for inviting me. Glad to be here today and share some of my experiences with you guys. So first of all, can you hear me okay? Is the audio working fine for everybody?
Yes, sir, we can hear you.
Awesome. So yeah, as Matumai mentioned, let's keep the session interactive. So I'll just share my story about building an IoT startup from scratch. And most importantly, I'll talk about the challenges we faced, right? Because like there are so many stories about the good things that we achieve, but nobody really talks about the challenges or the problems or the failures we faced in building an IoT startup. So that's where the most of the lessons come from. So I'll share those with you. And if you have any questions, please feel free to ask. I want to keep this session as interactive as possible. So yeah, I really expect to get some tough questions from all of you as we go through this session. So let me share my screen and get the session started. Okay. you can see my screen. Let me share the slides now. Yeah. Do you see the deck with the title Engineering Entrepreneurship?
Yes, sir, we can see.
Awesome. All right, let's get started, everybody. So again, thanks a lot for joining. So as I said, this is a story about how an IoT company came to life over like a period of about 8 to 10 years. So I'll share some of the insights, the challenges, and hopefully there'll be something for you guys to learn from and question about as well. So let me give you a quick bit of background about my story. My story starts from University of Moratuwa. I studied computer science and engineering, entered the university in 2005 and graduated in 2009. As you can see from the quality of these pictures, those days the phones we had were like Nokia's, right? So I'm sure many of you might not have even seen Nokia's, they're so old, but this is the best quality pictures we had back then. So after University of Moratuwa, I studied, as I said, software engineering at computer science and engineering department, and then moved on to 99X Technologies, software company based out of Sri Lanka. Worked there for about 2 years on Norwegian software development projects. And then after that, in 2011, I moved to Singapore to study at the National Institute of Singapore, where I did a PhD in computer science as well. So my research was done in partnership with Microsoft Research, and like we built like these kind of wireless based solutions for improving the quality of VoIP calls, or the calls that we place on applications like WhatsApp, Viber kind of things. But my research focused on Skype. I don't know like whether like any of you have used Skype. It's like it used to exist and used to be a very big like internet-based calling solution application, but now it has I think pretty much died. So the research focused on how we can improve Skype's call quality when users are placing Skype calls on Wi-Fi networks. So some of the techniques we built in my PhD like got implemented in Skype, and we published some very interesting papers. And I got my first patent as a part of this research work as well, together with Microsoft Research. So this was so I graduated in 2016, and after that, this is where the IoT stuff comes into play. Like I entered an entrepreneurship program where we discussed ideas for building startups, and we had this very cool idea about building an IoT startup that could help monitor various sensors that are used in construction and mining projects called geotechnical and structural sensors. So these kind of sensors are used in projects like in construction sites, mines, rail kind of projects. I'll talk about why they do this monitoring. But back in 2016, when we were getting started, so we saw that in many of these projects, the monitoring work is done manually using workers and handheld sensor readers, like what I'm holding here. So a worker would literally walk from sensor to sensor in a construction site, for example, and take a tilt reading from like this sensor, which is like a tilt sensor. So essentially what they want to monitor is like they place this sensor on a wall or a column or whatever the thing that they want to monitor. And then they take a tilt sensor reading manually using this handheld reader to see whether that sensor has changed, right? Because if the tilt reading has changed, that means that column or the wall is tilting over time, and that is a problem. So then they take action before the whole thing collapses. So that's the kind of monitoring use cases we wanted to solve. As I said, when we started in 2016, such monitoring was done purely through manpower and workers. And in Singapore, manpower is very expensive. So we wanted to see whether we can build a very reliable IoT solution using our PhD backgrounds in wireless networks to automate this process. So that was the idea, the initial idea, and how we went about creating it. So this is eventually over a period of years how like our solutions shaped to be. We had several different models for IoT transmitters that are compatible with various sensors used in these challenging environments like construction mining projects, where the construction or mining companies can simply plug in their sensors and get seamless connectivity through our wireless IoT devices. And then we had like dashboards and mobile apps through which they basically configure and monitor the sensor readings over time. So this is a video of how the solution works. So this is what I mean, like typically in a construction project, oops, sorry, let me try that again. In a construction project or in mining projects, there are these kind of very specialized sensors that monitor various structural parameters. So this one that you see here on the screen is a tilt sensor. So it is intended to monitor the tilt of this wall. So the idea is, again, when they monitor the tilt readings continuously, if the wall tilts, then they can take the company can take action before they know it collapses and a big accident can happen. So it's mostly like monitoring is done for safety and for monitoring facing various regulations in like a lot of countries. So what happens right now with our solution is that instead of like a worker having to physically visit this site sensor to take a reading manually, that sensor gets plugged in to our battery operated IoT devices, and then they form what we call a long range wireless mesh network. So if you are in IoT, you might have heard about IoT solutions or technologies like LoRa. So think of ours like a LoRa mesh. So it's not LoRa that we used. We use long range radios for each device. And the cool thing is they can basically talk to one another, or they will build a very reliable mesh network, a long range mesh network where each link, each blue line that you see in this diagram can be a few kilometers. So it can go between obstacles, it can go inside tunnels, it doesn't need line of sight. So essentially, wherever there's a sensor, it can provide connectivity through other devices placed in the same site. And finally, all of them send their sensor readings automatically to a central device called the gateway. And the gateway then uploads it to a cloud. So the same thing is compatible in mining projects as well. So this is a mining application where they monitor things like rock movement inside the mine. Right, so mining happens mostly underground. So just imagine when miners are mining underground, looking for gold and all the good stuff. Like if the walls collapse on top of them, it's a big problem. It's a safety risk, and it's like a huge environmental risk as well. So that's why, especially in mining and tunneling projects, they install various sensors inside the rock or in the walls to see whether there's any movement. So if there's any movement, then they get the people out very quickly before a bad accident can happen. So that's why these kind of monitoring applications are very critical. And that is the unique selling point of a solution. So no matter where they need to monitor a sensor, they can connect it to our devices, our IoT devices, and they form their long range mesh through the mine or through the bends, through the tunnels, whatever it is. Like the deepest mine we install in is in Africa. It's a 4 kilometer depth mine, right? So 4 kilometers into the earth. Just imagine, it's like crazy deep underground, and we help bring all those sensor readings through our long range wireless mesh into the above ground control room, where those people keep monitoring the sensor readings to see whether there are any unusual movements. So this is a mining application, and we've installed applications like monitoring solution, the solution on infrastructure like dams as well. Like in Taiwan, there's a big dam where we installed solution in, where they were monitoring the dam wall. So again, if there are any water leaks or movements in the dam wall, it can be a big problem. So that's why they monitor these things. And another application has been on railway tracks. So monitoring essentially the tilt of railway tracks, right? Because if the railway track has to be nice and straight, if the track tilts, it can affect the train operations. So there are like many rail applications that we have instrumented with our devices for real-time monitoring. So that's how the technology works, like how our IoT solution was designed and built. But like this is over like 8-9 years. We started from Singapore, so we started expanding all across the globe. So we've sold in all the different continents except Arctic, Antarctica, of course. But yeah, so in most of the other key markets, we've had customers. So in 55 countries to be precise. We were selling out of our main office in Singapore, and we had a regional office in Canada as well, covering the North and South American markets. So yeah, so it's a product that was very unique, and we had a very strong market all over the world. So yeah, so this is one like a couple of projects that we did with our solution. So if you come to Singapore, the Changi Airport is the major, the one and only airport. It's like the world's fifth busiest airport. So they built an underground rail network in the airport premises. So they installed our devices along the runway of the airport to monitor whether the underground construction is impacting the runway, right? Because if the runway gets impacted, it's very dangerous. The planes can't take off and land properly. So that's where they installed about 100 of our devices at the airport premises for real-time monitoring of the runway. And this is also a very interesting project. So this is in South Africa. I was lucky enough to actually go to this particular project. So these caves are called the Sterkfontein caves. It's essentially like the nickname for it is the cradle of humankind. Because it's called that because the first human fossils, human fossils, humans like us, were found in this particular cave in South Africa. So it's a UNESCO heritage site, very important in the history, the human history. So again, it's a deep cave underground. So they are monitoring, and because of like climate change and things like that, the cave has slowly been shifting. So they are monitoring the cave walls to ensure that the cave won't collapse, right? Because it's a big piece of our history. So yeah, so as you can see, we managed to like build the company to like a great extent. We just started from two founders. I showed you like the pictures that we took earlier. I'll show you now the first prototype as well. So from that stage, we built the company to like a stage where we were doing like few $1 million of revenue per year. We were growing year on 30 to 40% on in sales year on year. We've raised about $10 million, slightly more, in through venture capital firms for investing into the R&D and scaling the company. And the team grew from just me and my co-founder Mubashir to about 30 people across 5 different countries at our peak. So yeah, so we managed to like really scale out the business and do a lot with just like the IoT idea that we had. So essentially, this is what we started with. This is the first prototype we built. I did all the soldering work myself, like all this breadboard prototyping stuff was done entirely by me. We didn't have anyone else. And the programming of the firmware for our long range wireless mesh firmware was done by my co-founder. So that's how we split the work between the two of us. And then over a few years, we managed to take the product from this like prototype with breadboards and wires and hand soldered stuff into something that is mass produced and sold in like thousands now all over the world. But the journey from here to here, it's nice, right? As I said, like I showed you a lot of nice pictures, a lot of like sales, a lot of good stuff. But the journey from here to here was not easy at all. I'm so glad that when I started the company, I didn't have any hair, because literally if I had any hair, I would have lost it anyways by this time, because it was not a straightforward process at all. There were so many challenges, so many pitfalls that we had to navigate in building this IoT based company. So my goal during the presentation today is to, not to talk about my journey or anything like that in a lot of detail, but rather go through 3 key challenges that we had to solve in building an IoT startup from scratch. Okay. So these are the 3 big lessons that I learned myself. So again, I come from like a technical background, like most of you on this call. So I had to learn all these hard things, like in a very expensive way. So these are 3 lessons that I would like to share with you that hopefully would be useful in your entrepreneurial journeys as well. So let's talk about the first challenge, which is actually nothing to do with technology, right? It's about whether it even makes sense to build a business based on the product that you're thinking about. So this is the number one reason why most startups fail. Like if you look at like the startup all over the world, typically there's this 90% benchmark, meaning about 90% of the companies that start fail, right? So the chances of success chance of succeeding is very low. It's about 10%. But if you then look at all these failure cases, the key thing that you see in many of them is that they were building a nice to have product that they thought is very cool, but eventually when they try to sell it, there's no one to buy it. So that's the number one reason why businesses fail, or at least why most startups fail. So therefore, the first thing that you need to validate, even before you build a product and try to sell it, is whether you have a business case for what you're trying to build. And it's actually very simple. This is not about doing market research, doing like, a lot of research on ChatGPT or Google or anything like that. It's actually understanding like who you are trying to build it for, and then going and speaking with them. I'll give you some examples. So first, based on this idea that you have, you need to think about who the target customer is. So that's why typically, there are two ways of solving a problem. First, you have a solution, right, that you think is pretty cool, and then you try to find a problem where you can go and apply that solution. So that's not the best way of building a product, because you actually are looking for a problem that you can solve with your solution. So if you do it the other way, where you identify the problem and then you come up with a solution idea to solve that problem, then the chances of succeeding are much higher, because you're already starting with a known problem. So anyways, think about whichever path you take, think about who you are building it for, right? Who are you building this product for? So in our case, with the Axio case, we didn't know that anything about geotechnical monitoring or construction sites or mines. So what happened was, we went and I have a friend from Morocco as well. He studied civil engineering, and he's based in Singapore as well, and was working for a tunneling contract. So one day I was chatting with him, and he shared that because when they build the tunnel, they need to monitor all the sensors, and then because they use workers, it's very difficult for them to get sensor readings on like more frequently. The workers can only do it once per day, because there are like thousands of the sensors they need to monitor all over the site. So workers can only give him one reading per day. Then I said, like, why haven't you tried any real-time monitoring through like IoT or any other solution? And he said, like, there's nothing that works in these kind of tough environments. And that's when I got thinking, okay, we've studied wireless technologies before, like IoT technologies before, for our PhDs and the computer networks and stuff like that. So can we then like apply some of those stuff or some of those techniques in these construction projects for real-time monitoring? So that's how we actually got started. So likewise, like it's fine to start with the solution, but then really think about who your target customer is. And then once you know and identify that target customer, go and talk to them. So then you try to identify this, get more clarity on the problem that you're trying to solve. So, like, for example, let's think about agriculture, right? So you might be building an agriculture related IoT startup. So your key customer can be either the farmers or the middlemen, like maybe the fertilizer manufacturing company. So you have to really identify and narrow down who, once the product is ready, who is the person who is going to pay for it. And that's how you find who the correct persona or the people that you're building it for. And then you go and talk to them and validate the problem that you're trying to solve. Validate the problem means you're not asking, like, if I build this solution, do you think it would be nice? Do you think it would be useful? Would you buy it? Like, those kind of questions will most probably be answered with an yes, because those people have been, we are typically nice people. So we won't, even if you think that your idea is bad, if you ask me whether this is a good idea, whether you would pay for it, I would say yes, because I wouldn't want to hurt you feelings. But then later on, when you try and come and, to sell it to me, I might like hesitate, because I don't really want what you're building. So that's the tricky part about like identifying and validating the problem. So you need to answer these questions in a way where you identify exactly whether what you're building makes sense for them. So there are questioning techniques. I'll share a book in the next slide that is very useful for this purpose. But to give you an example, you shouldn't talk about uh, you shouldn't talk about your solution and ask whether it's a good idea. Rather, you should ask them, let's say you're solve like for yourself, like you're building an agriculture related startup IoT, and you are speaking with the farmers. And then let's say your solution is about helping them maybe find the exact time when they should put fertilizer so that they don't waste their fertilizer, right? So then you're building for farmers. So you should go and meet these farmers and you should ask them like, hey, how are you putting fertilizer into your plants? And then listen to him. So, and then ask about, what are the problems you have with that approach? Then he might say, oh, I waste a lot of fertilizers. Sometimes I put too much and my crops are wasted. And then you ask, okay, like, what have you tried previously to solve this problem? And then you say, okay, there's nothing really out there that can help me. It's all things are very costly. So I do it based on my gut feeling, right? So then you sort of like validated it and you sort of know what he has tried before. And then you like try to like basically dig deeper into identifying this or validating this problem further. So then like the third question is, why do they actually need the solution? Like, so this is the key thing. Like you need to identify whether what you're building is a painkiller or a vitamin, right? So the two are very different. Like let's say we are suffering from a very bad headache, we would take Panadol, right? Like it's very unlikely that we would continue to work or stay without trying to solve that pain because it's really hurting us. It's our lives are miserable. So we take the Panadol that we need to get rid of that pain. However, a vitamin is not like that, right? Like I know we are supposed to take vitamin D and vitamin C and all of that, eat a lot of vegetables. So sometimes we don't do it because even if we don't do it, if we don't take the vitamins, we still fine. We can still function. Our life still goes on. So it might not be ideal, but who cares? But so when it comes to startups or problems, the thing that you're solving or building should be actually a painkiller. That's when you would have a real market. That's when you would have real users who are willing to pay. So to identify whether what you're working on it makes sense, this is a very interesting book. It's called the Mom Test. There are actually I didn't want to share the link, but if you Google this title online, you would be able to find PDFs that people have uploaded. So just if you Google this, you would be able to find, or if you have the real book, or if you can borrow it from a library, just read it. It's pretty useful. It has very interesting conversational tactics that you can use to validate whether what you're building is actually a good problem to work on. So it's called the mom test. It's called the mom test. It's very interesting because the thing is, if you ask your mom whether you are a good son or a good daughter, the mother is going to say always yes, right? And if you ask the mom, hey, mom, I'm building this company. Do you think it would be successful? Your mom will always say yes because like you are the biggest champion in her eyes. So she wouldn't want to disappoint you. She would always say yes. So that's why it's called the mom test. You should ask the questions in a way that you would get real answers from customers that you're building for. So yeah, if you can't find this book, read it. It's pretty interesting. So then the ultimate validation that you should have in your hands even before you start building, the biggest, like there's a few ways of seeing like validation proof. The first is paying clients. Like let's say your idea or the product that you're building is so interesting to whoever you're building it for. And if they're willing to pay you even before you have built a solution, you have found a very interesting problem, right? So this is the best validation proof that any startup can get before, like, getting money from real users without even having a product to sell. So this was the case for Axio. Like once we had that initial prototype, we like getting the prototype done was easy, right? We got some off the shelf things and assembled it and put everything into a nice plastic box and showed it to one of these construction monitoring companies and said, hey, we have a prototype, would you like to try it out? And then they said yes, and then we managed to get some money from them that we utilized for our R&D efforts, and they actually gave us sensors, they gave us access to their sites to come and test. So that was the validation that we had. Like the client was paying us money and was helping us build a solution, and then only we started spending more time building the product. So if you don't have paying clients, at least try to get LOIs. So if you're solving like a B2B kind of like a business. So if you're selling to other companies, LOIs are typically used to show intent that they are interested in what you're doing, and they are interested in either doing a POC once the product is ready, or even buying the product when it's ready. Right? So this is the second best option. Third is, of course, clients, as I mentioned, helping you build a solution. So what you're doing is such a big problem for these clients. They are even willing to put aside their resources, their time, give you access to their data, whatever it is, to help you build a solution. Right? So if you have any of these signs, these are not the only things. These are three examples, but there should be some indication from the clients or whoever you are building for that they are willing to pay, they are willing to help you, they are willing to like sign LOIs, or like they are willing to work with you basically. And that shows you that there's validation in going ahead and building whatever you want to build. So that's the first challenge, right? Validating the business before you start. The second challenge is a bit technical now, essentially because we're talking about IoT in particular in this presentation or in this session. IoT involves hardware, right? And getting hardware right is really a big challenge. And this is something that we had a lot of problems with at Axio before we could get to the stage where we are mass producing in large quantities. So it's essentially we need to prototype and field test the solution extensively before you go into mass producing. I'll tell you a few of the problems that we had. So first of all, we didn't iterate on the product too many times. So we try to go to market as soon as possible. Like this is one of the examples. So there's one client who saw what we had and said, like, if you can miniaturize this, I can try to put it into one of my sensors and like make like wireless sensors rather than having my sensor separately and your device separately. Can we combine the two and make like a wireless sensor, right? So then we said, okay, wow, that sounds like a good idea. We went and told our engineers, hey, there's this company that's looking for a miniature version of our nodes, our IoT devices, and then we built it. So then, like, these are sudden decisions that we took, which eventually came on to bite us really badly, because like we couldn't test it much. We went into the R&D stages directly. We didn't field test it. And later on, supporting these kind of devices became a big operational headache for us. And also with hardware, especially the moment you go into making custom PCBs, custom hardware like devices, the cost for making reproductions is very high. So like, because most of these PCB manufacturing has to be done in at least slightly larger quantities, like 10s, 20s pieces. So if there is a mistake that you had made in your designs or in your simulations or whatever it is, then you have to basically throw away that entire batch and start over again. And just imagine, like, if you keep finding mistakes in every iteration, the cost adds up very quickly. So it's not like software, right, where you can delete the code, recompile, revert the Git repository into an older version, change add the bug fixes, and get it running again, right? Hardware is not like that. The moment you make a physical PCB or a device, it's pretty much is the case. And if there are any issues with it, bad luck. You have to go and try all over again. So that's why it's very important to like use existing components as much as possible before you go into custom hardware development. So exhaust basically the existing hardware options as much as possible. See whether you can buy off the shelf things, integrate them, and build a product before you go, and then you keep iterating that and make it really robust before you think about making your own custom hardware, right? Otherwise, the costs can add up, like what happened to us. The second thing that we did is essentially when we went and started deploying a solution in sites like this, then realized things work very nicely in our labs or in our offices, but when you go and put it in the field, something or the other goes wrong. Usually that is the case, especially with hardware. So, and in our case, it was really a big headache for us, because the moment something stops working, as I said, these are like safety monitoring. So if these companies are not getting the data from the sensors they need to monitor, it's a big operational challenge, right? Because what if something collapses that they were monitoring and they didn't have the data from our system to show that it was tilting? then it can be a big reputational damage for us, and there might be liabilities as well. So whenever there were faults, we had to send people on site and start fixing it. And that's when we realized, oh, we should have installed a feature where we could do firmware updates. So this was very difficult or challenging for us to build because our devices were communicating with these long range mesh networking protocols. So it was hard to disseminate firmware updates through such a complicated network. So that's when we actually realized we should have like at least thought about a different way of doing it, because without having this feature, we had to do lots of site visits, which added a lot of operational overheads to us. So this is again a reason, right? If you do more field tests, do more iterations, you would find these kind of missing features before it becomes a big pain for you. Third example, unforeseen failures. So our devices look like this essentially when the lid is open. So it runs on batteries. So again, in Singapore, when we were testing it in the office, everything worked fine. So one day there was this Taiwanese company that was interested in trying our solution, and we shipped them two of these devices to test. And then like they tested it, and then the next day they called us and said, your devices are not working. And then we thought, oh, maybe there was some manufacturing issue. So we said, no, no problem. We'll send you two free devices again, try them out, right? And this time at our office, we tested them thoroughly. We installed all kinds of different sensors and like made sure that they're working for like a good week or so. And then everything was fine. We put it into like the shipping cartons and we shipped to Taiwan. Again, the next day, the guy calls us and says, yeah, it's same thing. We tried to run it. The moment we turned it on, it's not working. And we were really puzzled. We didn't know what was happening because we tested everything. Everything works fine in Singapore, but for some reason, it's not working in Taiwan. And actually, they did ship back the devices to us in Singapore. And when we actually tried to use them, they were not working. They were completely burnt. The circuit was burnt inside. So we really couldn't understand it. So then we sent them another pair of devices, third time, but we told them, don't turn them on without us. And once they received the devices, we got on a Zoom call like this with them. And then they showed what they were doing to turn them on through video. And that's when we saw what was going wrong. That particular meeting room where they were testing the devices in had very low humidity, and they were having like the moment they touched the device to put the battery, this yellow color battery in, there's electrostatic discharge from their fingers into the devices. So it's ESD, right? Like this like tiny spark that we get when we touch something metal or in a dry environment, it happens, right? So basically that ESD discharge was happening every single time that they try to touch our device. And that ESD discharge was destroying a diode in our PCB. So we had no idea anything about any like ESD or the significance of it. And we only realized that it is a fault in our devices, a design fault through this experience. So just imagine we had made hundreds of devices back then. So we had to like basically recall all of them and like find that diode that is getting burned due to ESD, and then we replace it with a more with another model of the diode which had a higher ESD threshold, right? So those are kind of like problems that we experienced on site, which we had never seen before. So that's the thing. So if you're expert in industrial IoT, if you have done these kind of things before, like, if I were to build another industrial IoT startup, I have experienced these things, so I know. But if not, if you're doing this for the first time, go and field test it in different environments as much as possible, in like places where you want to test your solution in, and do field tests as much as possible before you go into mass producing. Because if there are faults like what I talked about, the cost of fixing those failures become exponentially high if you have mass produced everything before testing. So, okay, those are the technical challenges. Now I'll come to again some business challenges that again, as engineers, we don't really think about these things. And these are also lessons that we learned the hard way at Axio. So first of all, now, you found a problem, you have built a nice product and it works, you field tested it, it works beautifully. So you have mass produced it. And now how do you sell it, right? Earlier, the team is very small. You were probably selling, finding these from clients directly and selling it. But later on, you need to find a way to scale your GTM or the go-to-market strategy. So basically, because like if it is like your sales team, if you can only sell directly, then you need to hire like a good sales team, train them, and have them like make all the resources they need. They're like the sales decks, their marketing materials, videos, brochures, illustrations, whatever it is, right? That your sales team would require to go and sell it. Or else, like if you are selling in other countries, like what we did, we started appointing distributors in different markets, because we are a small company. We can't have salespeople in like 55 different countries. So what we did was in key markets, like in Europe, the US, Canada, South America, we had distributors that we work with. So they essentially buy from us and then sell within their markets, right? So there was like a lot of work in finding good distributors, training them so that they can represent us on behalf of us in Singapore in different countries. And thirdly, we partnered with other companies again to open up even more sales channels. So partners in our case, in Axios case, because we were building IoT devices for these construction mining sensors, we went and spoke with these sensor companies and said like, hey, you guys have very cool sensors, but people in construction sites or in mines are monitoring them manually. But if you partner with us, you can sell our IoT devices along with your sensors to provide a full solution to your clients. And that worked out. So we worked with a few sensor companies like that. So whenever they sold their sensors, they referred their clients to us so that we can sell them, the same client, the IoT solution to monitor those sensors, right? So you need to think about how you can essentially reach your clients as fast as possible with as little resources and money as possible. So that's how your GTM strategy works. So again, like when you think about the product, at the early stages, this doesn't really come into play. But when if your product is working and your clients are liking it and you want to expand, you need to think about your sales channels and the sales strategies. Then manufacturing. So again, prototyping is easy. You might get like off-the-shelf components, put them together. But later, when everything is working, and if you are building a custom hardware, to scale up the manufacturing, you need to work with contract manufacturers. So I don't know whether any of you been to a contract manufacturing facility before. So this is a picture of the facility we use in Indonesia. So basically, it's like a factory, essentially. So each machine is like a soldering machine that can churn out PCBs fully soldered with all the chips, the resistors, whatever the components you're using, based on your design in like thousands of units at like in a very short amount of time. So basically think of them like photocopying machines that churn out exact clones of what your product is in a very short amount of time. So you need to work with these kind of companies to really scale up your manufacturing for whatever the devices you're making. So working with them is a challenge again, because you need to give them your proper designs, and they are the ones who are like manufacturing them on behalf of you. So you have to work very closely with the CMs, have like test jigs through which they can test out your devices on behalf of you, so that like their quality controlling processes, everything is carried out before they get shipped to your clients. Right? And then on the financial side of things, this is also something that we learned again by doing a lot of mistakes. There's a term called working capital. Again, if you're an accountant, come from a finance background, you might be familiar with it. I was not. I came like purely from a computer science background, so I had no clue what working capital was. This is essentially a very fancy word about how you manage the cash of the company. So as I mentioned, for Axio, we raised funding from venture capital firms. So we were not using that cash effectively because in Axio's case, we had to maintain inventory. We can't make to order because the client would contact us and say they need 50 of our IoT devices next week. So we need to keep inventory, and keeping inventory is expensive because inventory, like we need to first pay our contract manufacturer, make the devices and keep it in our stock, waiting for orders to come, right? So until we sell those devices, our cash of the company is stuck literally on shelves, waiting to be sold. So if you don't manage that cycle properly, cash gets stuck in inventory. So the working capital requirements go up and you have very little cash to run the business with. So it becomes a problem. So then you need to find the correct like inventory levels so that you have enough amount of stock so that you can fulfill the orders and also have enough cash in your bank to like, pay salaries, pay rent and all of that as well. So managing working capital is also a very tricky thing. It needs to be done, especially in hardware companies. It has to be done very carefully. Or like best case is if your product can be made to order, like if a client can wait, let's say until you make the product for them, it's like ordering at a restaurant, right? Like you wait until your food is made. So like that, there are companies that make to order. But if you are like if the client can afford to wait for like the product to get ready after they place the order, then it's fine. Then your working capital requirements would be low because you don't have to keep inventory. But if you are like us and you have to keep in inventory, then this working capital management becomes a key thing. And then finally, the pricing model is important. So in the beginning, when you start, pricing is probably not the key thing that you're thinking about. But then when you grow the business, your pricing needs to make sense. Basically, you need to have good gross margins so that your margins can cover your operational expenses and eventually make the business profitable. And you need to have scalable unit economics. So unit economics is again very simple. There are two terms, CSC, CLV. CSC stands for customer acquisition cost. CLV stands for customer lifetime value, meaning how much are you spending to acquire a customer and how much value is that customer giving you for the entire time they stay with you. So let's say you spend $1 to acquire a customer, and then that customer is paying you $1 for your product, then your business is not scalable, right? Because you spend $1 to get $1, basically you're not making any money. Worst is if you're spending $5 to get a customer and they are paying you $1, right? Then your acquisition cost is higher than the lifetime value of the customer. So the business doesn't make sense at all. So typically, as a rule of thumb, you should at least have the customer lifetime value 2 or 3 times of your acquisition cost. So in Axio's case, we go to trade shows, we do like site visits and all of that. So those are our customer acquisition costs. So we need to ensure that the customer acquisition cost or the price that we sell, eventually the lifetime value of a client essentially covers up that cost by at least 2 to 3 times. So yeah, that brings me to the end of the talk, essentially. So what I wanted to share was like 3 key lessons, and to summarize, some advice, to you and even to my younger self as well, because I had no idea about these things when I started Axio. So these are all lessons that I learned the hard way. So first, validate the business before you even build anything, because if there's no like validation, or if you're not building a painkiller, you will sadly find out that there's no business and you would have wasted a lot of your time, a lot of your money and resources for nothing. So ensure that what you are building is validated and there's a business case for it. Second, iterate. So build the leanest possible product. Like try to get, as I said, like off the shelf modules, try to integrate, put them together. It doesn't have to look nice and pretty at the beginning. So try to field test it, get feedback from the clients, and then test it, uh, and then iterate. Right. So keep the customer always involved in your productization process. So the moment you have something that is workable, it doesn't have to look polished. Give it to the customer, ask them to test. Because again, remember, if you're solving a painkiller problem, the customer would be more than happy to test a half-baked solution because you are solving a very key pain for them. So they'd be happy to work with you to help test whatever you're building, give you feedback so you can go and improve it, because they also get benefits by working with you. So this is why you should keep the customer always in the loop of during your productization and the iteration phases, right? So when you keep doing this over and over again, the product becomes better and better. You have more real feedback from like the real customers you're building for, and then eventually you'll have a very nice product that people would be like more than willing to pay for. And thirdly, think about how you're going to scale this, because when the business makes sense, you have built a good product. The third thing is to scale it. Like how do you get it into the hands of more customers as cost effectively as possible, so that you can build a big business out of like your idea. So these are the three, I think, key lessons that I would like to leave you with to think about. Again, like if you have any questions, happy to go through them now. I have given the QR code. This is my LinkedIn profile. So like I share these kind of like stories and my insights to help fellow entrepreneurs on LinkedIn regularly. So if you'd like to see those stories and hear some of the experiences, follow me. Yeah, I raise post at least on a weekly basis. So there would be things that you might be interested in. Yep, and that's it. Yeah, I'll open up the floor for questions now. Mahatma, how are we getting questions? Are we allowing people to unmute and ask them?
They probably put on the chat, sir. Or
Okay, so there's one question here. Yeah, got it. Okay, so there's some compliments about the books and stuff. That's good. Like some people have found the book already. Okay, so do you think there's one question here? Do you think building a startup is better, safer, alone, or with a team? Definitely, you need to have a team. So typically, like good companies at least have two co-founders. Because at the beginning there's a lot of work. So I'm running my second startup now again with another graduate from Moroto, CSE as well. So we have again, like, ways we complement each other. Like I take care of like the business, the sales and the problem validation, like those kind of things. My co-founder is really good in the technology side of things, like building the product. So that's how we sort of split responsibilities. So it's always better to do it at least with another person at the beginning, because you might complement each other in different skill sets, and also there would be blind spots that you might not see where that the other person would have observed. So always try to form a team and work together with at least someone, but make sure you have complementary skill sets, right? If both of you are really good in building the product and nobody's really good at talking with clients, then it's not a good thing. So one of you will have to spend more time with customers. So make sure you balance those responsibilities out. But yeah, short story, do it as a team. So then I think there's a question for you, Mohatavi. Competition එක කවදද තියෙන්නේ? When is the competition? Okay, someone answered it already. Refer our website, sliot.cscmrt.ac.lk. Okay, there's a question here. How can we do solution validation without exposing our idea completely? So this is again, I think, a very interesting question actually. So people are very afraid to talk about the idea because they're afraid that someone will copy it and build something on it. But actually, you should not be afraid, because if the idea is so simple, that means somebody else might have already done it. That means you need to do a bit more like validation. You to speak with these clients in more detail to see whether they have like come across something similar to what you're working on. Yeah, and as they say, right, ideas are cheap. The real value is in the execution. So like a lot of people can have the same idea, but only a very few people are actually willing to put in the effort to build a real product and make a business out of it. So you should not be afraid to talk about the ideas at all. You should go and find as many people, as I said, like that are relevant to what you are building, and discuss with them, get their thoughts, get their feedback, because that will only help you improve the idea. So don't be afraid to talk about the idea at all. At what stage is a patent required for a product? Okay, this is also a very interesting question. So I would say a patent is not required at all, unless like there's some really fundamental like technology or brand new technology, and this patent itself could be like a big asset for you going into the future. Like especially if you're raising from VCs or investors, they would like for you to have a patent, because That is their assurance that what you have built is first of all innovative, and secondly, you have a patent. That means no one else could do it, because investors don't really want to, like, give you money, and then if someone else comes up with the same product and then undercuts you, then their investment in you is wasted. So one way of like meeting these investor sort of, it's called defensibility, right? The investors would ask you, how defensible is your product? And then if your answer is it's very unique, you have a patent on it, so therefore no one else can do it, then it's a really strong answer. And then it sort of checks like this defensibility requirement with investors. However, if you are like, again, I have seen companies where they don't have any patents at all, but still what they build is like a trade secret, like Coca-Cola, for example, right? Like nobody knows the Coca-Cola recipe even now. The company is like over 100 years old. So there are companies that are successful like that as well. So essentially, you can have like a good technology and you want to keep it secret because of, like, again, that is a strategic advantage. That is fine as well. So think about whether you really need a patent, because the patenting process is expensive, it's long. So if you really need it, if you think it will add value to it, go for it. Like, it could all, there are cases where some companies buy your patent as well by giving you royalty and things like that. So if you want to go or try that kind of like an angle, it makes sense to have a patent. Otherwise, it might not. So just think about why you're trying to patent it, first of all. Whether you need a patent or not is a different question. If like you want the patent to really protect yourself from other competitors, or to like demonstrate to an investor that your technology is really defensible, then go for it. Otherwise, just think, whether you really need it. Okay, this based on the team. Basically, we give stakes and start. So in my case, I have already. Do I need to pay them and give them? Okay, so at the beginning, right? So I don't know exactly. So this question is from a student here, I think. So the question is essentially asking, like, there's a team, and then we need to give a stake of the company, and then if you have already partnered with other companies, we need to pay them and give them stakes also? So it depends again how you want to structure it. So usually at the beginning, if you don't have any funding, if you don't have any money to pay to other people that work with your idea, it's only equity that you have. So the cleanest split is like, let's say you're two co-founders working together, then you split the company 50-50, right? And then that's how you start with. And then later on, if any other people help you, you might give them certain ownership stakes. Or if an investor invests in you, or like an angel investor, you might give them some share or a stake in return. So that's how typically works. And then there are advisors who you might bring on board. So they will not get any money from you. They won't ask for any payments from you, but rather they will give you their guidance and their expertise. They might help you introduce you to other like companies or clients or whatever it is, and then they might take a small ownership percentage from the company. So that's typically how these ownership things are handled. Again, if you have like a very specific thing, feel free to send me a message. I can look into it. But usually that's how the ownership is distributed. Like stakes are given to co-founders, early employees, like advisors. Yeah, typically not to clients. They don't need stakes, right? They are, because if they are asking something from you, like ownership, then it's a different thing. Like for example, like given one story when we were building Axiom, one of the clients that we were speaking with, a potential client we were speaking with, helped us. They gave us like their sensors, they gave us their sites, and then they said, okay, I will help you build a solution. You need to give me X% of your company. And then we discussed with our advisors, and they said we should not give ownership to clients. That is like a conflict of interest. And then other clients might also either ask for stakes, or like if a client knows that one of their competitors is already one of our shareholders, then it might create problems. So later on, we stopped working with that company. We said, thank you very much for helping us so far. We can't give you any like ownership stakes of the company just because you helped us. So we, closed that door. So yeah, think about exactly why you want to give a stake, and then if it's meaningful, go for it. Yeah, you should do it.
Hi, Mr.
Uh,
Nimantha.
yeah,
Can I talk with you? Yeah, so basically, I was the one who put that question for you.
yeah.
So
Hi,
my name
Chandru.
is Chalindu. So actually, the problem which I'm facing is right now. So basically, we have already done with the MVP. So MVP is tested as well through a company. So basically, I'm developing a medical product for maternal health care. So we have actually go for local, I mean, national and global competitions, and we also won those competitions as well. So I
Nice.
thought of scaling it up as a commercializing product. So right now, what we did was I have my team as in like so me I'm there, and then afterwards I have an software engineer, and then afterwards biomedical engineer, and then other people are like actually advisors.
Mm-hmm.
So right now, so though we have done with the MVP, so when we are going for the commercializing part, actually, my concern is so basically we don't have much funding right now. We got shortlisted for UNICEF Venture Fund and other grants from local governments, but
Okay.
right now for our banks, we just got shortlisted, didn't receive anything, right? So how can we actually survive this time period where we until we get the proper grants and everything? Like how we convince them like to work with us and everything? I actually feel like guilty when I'm going for that. So that's why I ask you whether do I need to? I obviously we need to give the stakes. Apart from that, like how we actually manage the first period.
Yeah, exactly. That's where, of course, the equity comes into play. So if they really need cash to work with you and you don't have cash, then unfortunately, there's no real solution for it. But if you can talk to with them about, this is where the selling skills become really important. If you can show them a picture of, you like do this for, let's say, whatever X% of the business, like a small stake of the business, and then over the next 1 or 2 years you are going to get like these funds in, and by that time the company's valuation would be like Z, and like X% of Z is like huge. It's not compared to compared to the $1,000 you're asking me for now. In 2 years time this X% might be worth like $500,000, whatever it is, right? Just to paint them the future of what that ownership could look like, so that they get motivated to work with you. But some people, I've had this challenge with Axio as well at the beginning. I mean, some people don't really care about equity; they want cash. They have bills to pay. It's understandable, but then it's tough, Charlie. Then there's nothing much you can do. So try to find people that that are willing to work for equity in that case, and yeah, or else maybe like who would be willing to work with you and accept a payment when the grants come through, right? You can also arrange those kind of deals with them. So just try to be a bit creative in figuring out how you can get them engaged, but incentivize them in the future.
Right, Bismal. Thank you so much. And there was another concern. So basically, if I'm getting a partnership, as in like to get a support from the, obviously we need to, while we are scaling up, we need to go for a partnership where we do hardware manufacturing with another company. At that moment, so basically I can convince them, if I can convince them after we receive the grants and then afterwards uh, doing the payments, so that would be possible, right?
Yeah, exactly.
Right,
Exactly.
right.
Yeah. So, I mean, there are other, like, I don't know about Sri Lanka, but at least in Singapore, there are these kind of like PO financing schemes, meaning there are people, like, let's say you have a PO from like, say, a client for your solution. You can show that PO to these funding like services. They are kind of like banks. They see the PO as like, proof that you are going to get payment in the future. So then they will give you that PO value upfront, basically what the customer was willing to pay you, right? Because if the customer pays you upfront, it's perfect, you have cash. But if not, if they at least give you a PO, there are services where you can show the PO. It's called PO financing, and then a bank or whatever the funding thing will give you that money upfront, and then once the customer pays, you need to pay those guys back with some interest. So there are like those kind of options as well. So again, I'm not very like sure about your particular situation, but yeah, just try to be creative about how you can handle this kind of thing. This is like one of the things that as founders, we need to do, like figure out creative ways, creative solutions to sort of get unstuck and move forward.
Right, Mr. Nimantha, thank you so much.
No worries. Thanks for the questions and thanks for unmuting yourself as well. Okay, so what kind of sensors can you use to detect human heartbeats that are further away? I have no idea. Not an expert in the sensor space, so this is something that you need to like do some research about. But again, thanks to like these AI tools these days, doing these kind of like desktop research is pretty easy. So use things like Grok, Claude, or ChatGPT, or whatever your favorite AI tool, and see what it can find for you. I'm sure there should be some research done in this space. How do you choose the recommended software language for IoT programming? Yeah, so this is also depends totally on the application. So in our case, because we were programming on uh, what are they called? SoC, system on chips. They had very limited memory, so we had to program everything using embedded C. But again, if your application is something like that uses something a bit more powerful, like ESP8266 or Raspberry Pis or Arduinos, then maybe you can, like especially for Raspberry Pis, right? They have more computing power, more RAM, so you can use things like Python. So again, totally depends on the application, and then use the programming tool accordingly. Uh, uh, Okay, we used to find a problem that is worth solving, like a solution that people. So this is a tough question to answer. So it's hard to go looking for problems. So typically, good ideas for problems come from, like, like if you happen to experience that pain yourself, then that's another way of starting. Like for example, I know a lot of founders that I've networked with. They started their company to solve a problem that they saw in like whatever their work that they were doing. Like for example, one of the founders I work with came from like logistics side of things, like things like shipping, DHL, FedEx kind of services. They used to work for those kind of like companies, and I've seen a lot of inefficiencies in how these logistics service providers operate their freight channels, a lot of costs that are like spent unnecessarily. So then they came up with an idea to basically a product targeting those freight companies to help them reduce costs, right? So then like that's an idea that was basically that's a problem that they've observed themselves, and then they decided to build a solution for it. So usually there are like when it comes to finding like a founding a successful company, there are three like edges. They're called like edges or uniquenesses that you would have as a founder that allows you to be successful, right? So one is this domain edge that I talked about. So a domain edge is essentially something that you know about a certain domain that not a lot of other people know about, because you've been working in that domain, maybe because you have a lot of contacts in that domain, or like your mom might be working for like banks, and you might have seen a lot of inefficiencies bank, or your father or uncle or whoever it is might be a farmer, and you would have seen the struggles in farming or like farming related businesses, like like some domain expertise. So that is like through which you can get very cool problem statements that you can try to solve, and that is like one way of succeeding. The second is product edges. Like maybe you have built lots of very like interesting products before. So based on the product experience, you have found like product ideas that fill the market need, and you can, that's a problem that again you can attack. Or the third is like a technical edge. Like maybe you might be very good at like a certain technology, like I don't know, like cybersecurity or AI these days, like some with deep technical area where you have done a lot of research, have a lot of expertise in, and then you might have found an interesting problem space that you can solve with this technology. So these are the typical three like unique things that you might have that would help you build a successful startup. So the advice here, again, this is why I like went on a long road to answer this question, but the key message is don't go looking for problems. The problems should be naturally observed by using any of these three methods. So that's how you would find a good problem to solve. When you do a project, how did you research data or info? Is the easy way to research or standard way to. Okay, so back then this was tough. Like when I started Axio, there was no chat GPT or anything, so it was very painful. This is like the like why startups are hard and why nobody why a lot of people won't do it, because we actually need to spend time talking with customers. Because again, coming from engineering backgrounds, we are very comfortable sitting behind our computers, building beautiful products. But then when you try and sell it, nobody wants to buy it. So to do research, to identify these problems, you need to go and meet your customers, spend time with them, see how they're solving the problem that you are trying to solve. Like right now, because if it's a big problem, they should have found some way, some inconvenient way through which they're trying to solve it. Right. And then you might also observe that the problem that you thought is very big for them might not be that big after all. And it might be a bit of an inconvenience, but it's something that they don't really want a big high-tech solution for. They might be just happy doing whatever the manual thing that they're doing, and they don't really want an automated solution for it. So, right. So when you spend time speaking with these people, spending time with their customers, you would identify these kind of things and validate whether what you're trying to do makes sense or not. So essentially to do research, of course, there are these days things like, like Grok, ChatGPT, Claude, and these are AI tools, but nothing beats you being with your customers, speaking with them and getting feedback. What challenges do you see that a Sri Lankan entrepreneur researcher has compared to larger? Um, so this is a bit tough because I have not, although I am like originally from Sri Lanka, all my startup experiences have been in Singapore. So I've not built a company in Sri Lanka, although I've worked with Sri Lankan teams for my startup. So I would say the market is pretty small, first of all, but that itself does not mean it's a bad place to start. Because there are companies that have started in Sri Lanka that have become extremely successful, right? So like just make sure again things like market space, market size, and all these things can be solved. Like earlier, funding used to be quite difficult, but then now there are Sri Lankan-based VC firms, angel investors that are investing into tech startups. So a lot of these tech hurdles that used to be in Sri Lanka are not there anymore. So, and then there's like talent like you guys, right? Like that are already there. So it's never a bad time to start. And yeah, so exact challenges I'm not sure, but if you have an idea, if you validated it, and if you're based in Sri Lanka, there's no reason why you should move to like San Francisco. Of course, like there would be many more investors in San Francisco, in Singapore, in other places, but still, if your idea makes sense and if it can be built in Sri Lanka, if there's a market for it in Sri Lanka, you should start and see how you can build a good business based out of Sri Lanka and figure out how you can scale it to other countries, following those GTM strategies that I talked about. So yeah, I don't think there's any excuse about not building a company in Sri Lanka. If you're based there, the idea makes sense, validated, yeah, you should consider it. Fundraising methods for fresh startup founders in Sri Lanka. Again, as I said, there are angel investors. There's like the Lankan Angels Network. There are VC funds like Ventures that are operating out of Sri Lanka. So yeah, speak with these people. There are ways of getting funding. So you need to go and start speaking with these investment communities and see how you can get some funding for what you're trying to do. But as I mentioned, investors won't give you just funds, right? So they would want to see some real progress in what you're trying to build. So that's where this validation, paying customers, customers who are helping you, like these are real like validation checkpoints that investors look for. So before you try to find funding, make sure that you have like done your research, you have built or at least found an important problem, you have found some paying clients, hopefully, and you build like a certain prototype and you iterated it, you've gotten feedback from customers to show to these investors that you are like now starting to build a very good business that has the potential to grow. And that's when they would give you some funding to scale the business. Right. So like investors won't necessarily give you funding for an idea. Those times don't exist anymore. So you really need to have some proof about what you're building and whether it makes sense. foreign investors to fund you. Yeah, I think that's it, Madhumai. Yeah, I think maybe that's all for today, at least from my end. Yeah, it's already 11, almost 11 o'clock here, 11 p.m. So we can wrap up.
Okay, sir. Thank you so much, Dr. Nimantha, for sharing your time, expertise, and practical insights with us today. The perspectives you have shared will be extremely valuable as we move forward with the SLIoT Challenge 2026. Thank you so much. As we conclude, I would like to invite the chairperson of the SLIoT Challenge, Mr. Bhuvaneka Halpage, to deliver the vote of thanks.
Hello, am I audible?
Yes, you're audible.
So good evening, everyone. I'm Bhuvaneka Halpage, the chairperson for the SLIoT Challenge 2026. On behalf of the entire organizing committee, it's my great pleasure to deliver the vote of thanks for today's inspiring session. First and foremost, we are truly honored to have Dr. Nimantha Baranasuriya with us today. As a distinguished alumnus of our department, he continues to make us proud through his remarkable journey in research, innovation, and entrepreneurship. From building Axio into a global deep tech company serving over 50 countries, to leading Thermotive in driving sustainable industrial solutions, Dr. Nimantha's career is a powerful example of how ideas can be transformed into real-world impact. Sir, today's session gave us practical insights, deep motivation, and a clear vision of what is possible when we combine technical excellence with perseverance. We are especially grateful for your willingness to give back to the university and inspire young innovators like us. On behalf of the Department of Computer Science and Engineering, thank you for your time, wisdom, and encouragement. I would also like to extend a special word of thanks to our compeer, Mathumani, for guiding us through today's proceedings so gracefully. And finally, to all the participants joining us here today, thank you for your attendance and your enthusiasm. We hope this session has sparked the inspiration you need to kickstart your journey in the SLIoT Challenge. Thank you all and have a wonderful evening.
Yep. Thank you, all of you again. Very happy to have been here. Thanks a lot for inviting. All right. Good luck,
Thank
everyone.
you, sir.
Okay. Bye-bye.
Thank you, Mr. Bhuvaneka. This concludes today's entrepreneurial workshop. We warmly encourage you to apply the ideas and tools shared today as you continue developing your IoT solutions. Thank you all for joining us. Have a wonderful evening and we wish you all the very best in your IoT journey. Signing off, I am Madhumai Swendar.